Okay, Lewis structures. We've looked at Lewis structures for atoms, and we've shown how you can predict ionic compounds using Lewis structures. Now we're going to look at how to draw Lewis structures for molecular compounds and polyatomic ions. And this is where Lewis structures are used. We don't really use them to do ionic compounds much. So these are the instructions for how to draw Lewis structures. And this is kind of like balancing equations. There's not one exact way, do this, 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 this. There's some kind of, well, you could do it this way or that way. So you kind of have to just practice a lot and kind of get a feel for it. But these are the general directions. So the first thing is, write the correct skeletal structure of the molecule. How are the atoms connected to each other? So guidelines there, hydrogen atoms are always terminal. A terminal means the end. So a hydrogen atom, because it only has one electron, can only form one bond. So it cannot be in the middle of a structure and bond with two other atoms. It always has to be on the end. And then when we're not sure how to put things together, we're going to put the more electronegative atoms on the terminal positions. We know from observation that they tend to be on the outside of a molecule instead of on the inside. Step 2 is to calculate the total number of electrons for the Lewis structure. And electrons for the Lewis structure are going to be the valence electrons. So you look at the valence electrons for each atom and you add them up. And then if you have an ion, you have to consider the charge. A positive ion, you have to subtract some electrons. A negative, you have to add. You take that group of electrons and you spread them around. So we'll distribute the electrons among the atoms, giving octets to as many atoms as possible, remembering that hydrogen only wants a duet. Now sometimes you run out of electrons. You don't have enough to give everybody an octet, and that's where we have to do a little more sharing, and we're going to end up with double or triple bonds. Okay? So let's do some examples. Write the Lewis structure for carbon monoxide. Well, the first thing is show how they are connected. Well, since there's only two atoms, this is pretty easy. The carbon must be connected to the oxygen. There has to be a minimum of a single bond between atoms, or they're not part of the molecule. So the next step then is to figure out how many electrons are we going to show in this Lewis structure. How many valence electrons? So how many valence electrons does carbon have? Valence electrons. 4. So remember, valence electrons is the group number. So 4 for carbon, and how many does oxygen have? 6. Okay, so we've got 10 valence electrons. We're going to show 10 electrons here. This is a single bond, that's 2 electrons. So this is where we do some counting by 2. So I've already got the 2, 4, 6, 8, 10. I used up all my electrons. Does each atom have an octet of electrons? No. If it helps, you can think of this as having a dot at each end. I'm not going to draw them that way, though. And when I put those around, I just kind of spread them around. You just kind of spread them around. I don't want you to think about, well, these electrons belong to carbon and these electrons belong to oxygen. We're just going to group them all together and distribute them. It's like sharing, you know, a group potluck or something. You bring the food, you put it all on the table, and then everybody takes what they need, right? You don't say, well, this is my lasagna. I'm going to sit over here in the corner and eat my lasagna, right? You have to sit over there and eat your green salad. You put them together. And so that's what we do with the electrons here. Okay, so we don't have enough. That means we need to share more. So what we can do is we can take a lone pair from one of these atoms and share it. So I'm going to just take this lone pair, erase it, and then put it as a bond. So I still have 2, 4, 6, 8, 10 electrons in my structure. But now this oxygen has 2, 4, 6, 8, and this has an octet, so we're closer. Carbon still doesn't have an octet. It means we need to share more. If I take this lone pair and share it, then oxygen's going to have too many. So what I want to do is I want to take a lone pair from oxygen and make another bond. So we're going to have a triple bond now. And so we've got 2, 4, 6, 8, 2, 4, 6, 8. Carbon and oxygen each have an octet. Any questions? It's the Lewis structure for carbon monoxide. Now, it could be drawn in different ways. You could draw it like this, or you could put those dots, on the bottom, or on the top on one and the bottom on the other. That doesn't matter. It's all the same. Okay, let's look at this one. H2CO. Well, that's a little more complicated, isn't it? So how do we put those atoms together? Well, the rule is that hydrogen has to be on the outside, has to be terminal. So let's focus on the carbon and the oxygen. What's left, they're going to be connected to each other. And then we have to decide, well, should we put a hydrogen on each one? Or what should we do? The other guideline there is that electronegative, the more electronegative element is likely to be a terminal atom. So which is more electronegative, carbon or oxygen? Which one's closer to fluorine on the periodic table? Oxygen. Oxygen's more electronegative. So a good first guess is to say that the oxygen is going to be terminal. So we'll put both of the hydrogens on the carbon so that the oxygen is just bonded to one thing. That's what terminal means. So here, this hydrogen's terminal. It's not bonded to anything else after the carbon. This one's terminal and that one's terminal. And sometimes you make your structure like this and then you realize it's wrong. It's okay. Do these in pencil. So now we have to figure out how many valence electrons. Well, we already looked at carbon and oxygen. So carbon had 4 valence electrons, and oxygen had 6 valence electrons. And then we've got 2 hydrogens, and each of them has 1 valence electron. So in this structure, we've got 12 valence electrons. We already have 2, 4, 6 as bonds. So we're going to put some more, 2, 4, 6, 8, 10, 12. I've run out of dots. If you don't understand why I did anything, just stop me as I go along. So we have to make everybody happy. We need to share more. So this carbon has 8 electrons right now. It has an octet. Oxygen does not. So carbon is happy. So I'm going to take this lone pair from carbon and have carbon share it with oxygen. The carbon will still have 8 valence electrons, an octet when it does that, but now oxygen will get more. So I still have 2, 4, 6, 8, 10, 12 electrons. Carbon has 8. There's 4 lines around it. Oxygen has 2, 4, 6, 8. Hydrogens are always happy with just a single bond, so we don't have to worry about him. Any questions? Yes?
Can you say one more time why carbon is in the middle?
That's okay. Yeah. So why again is carbon in the middle? So let's go back and look at the directions here. When we're writing the skeletal structure, put more electronegative atoms in terminal positions. So the terminal position is like on the outside. If you go to an airport, and they'll say, oh, your flight is taking off from terminal B, right? So here you've got the main part of the airport, and then the terminals are these long hallways, long wings that come off. So oxygen here is terminal. You go out to the oxygen, and there's not another atom after it. So that's what terminal means. This hydrogen is terminal. This hydrogen is terminal. This is a central atom, this carbon. It's bonded to 3 other atoms. Does that help? Any other questions? Let's do an ion. What's the name of that ion? ClO minus. Hypochlorite. Okay, so again, the skeletal structure here is easy because it's just two atoms. They've got to be connected to each other. Valence electrons, how many does chlorine have? 7. And how many does oxygen have? 6. And what do we do with the negative charge? We have to add 1 electron. Remember, electrons are negative, and so a negative charge means that you have an extra electron. So this is 14. So I've already got 2 for the bond. 2, 4, 6, 8, 10, 12, 14. Cool. I was able to give both atoms octets without making any multiple bonds. The one thing that's missing here is this is an ion, and we have to show that in our structure. We're going to put brackets around it and put the charge on the outside of the brackets. Because as we learned on the last exam, ClO and ClO minus are different things. One's chlorine monoxide and the other's hypochlorite ion. Any questions?